Okay, let's give you guys some more practice. So find the limit of this sequence as n tends to infinity. So press pause and have a go. Okay, so to do this, let y be this thing here, and then now natural log equally to both sides. So natural log this side, natural log this. This will then come down here. That will then give you this natural log, the complicated bubble here. So once you're here, visualize it as one block multiplying another block. So this block here will get multiplied to the top. That will then give you this, and then now check it as n tends to infinity. This thing here is just going to get bigger and bigger and bigger. If you look at the natural log graph, this thing here is just going to get bigger and bigger and bigger. So this thing here is heading towards infinity. And then as n tends to infinity, this is also heading towards infinity. So you've got infinity over infinity, which is an indeterminate form, which means you can apply L'Hopital's rule. So applying L'Hopital's rule differentiates this. It will then give you this whole thing here. Differentiate this. That will then give you 1. So when you come to when you come to differentiate this, visualize it as natural log of a bubble. So when you come to differentiate it, it will give you 1 over the bubble, which is this thing here, and then times the derivative of the bubble itself, which will then give you this. Remember, if you have y equals 4 to the power of n, if you differentiate this, remember it will then give you it will then give you natural log of 4 times 4 to the power of n. So, well, differentiate this, it will then give you this whole thing here. Differentiate this, it will then give you this thing here. You should know how to differentiate this by now. Okay, so now you've got something over 1, which is let's just forget about this over 1. And then this thing here gets multiplied to the top of the fraction. That will then give you this. So this bit here is this bit, and then this gets multiplied to the top, giving you this. And then once you're here, here's a trick. Once you're here, divide everything by the highest of the two here. So here, divide top and bottom by 7 to the power of n. So by 7 to the power of n. So if you look at this, get this divided by 7 to the power of n, and then if you look at this here, divide this by 7 to the power of n. If you look at this, get this 7 to the power of n, natural log of 7 divided by 7 to the power of n. These should cancel out, giving you just this. And then divide this by 7 to the power of n. This divided by 7 to the power of n will give you 1. So basically, divide everything by 7 to the power of n. That will then give you this. And then if you look at this here, don't forget this is a constant. So by glancing at this, you should be able to tell that this goes to 0. The whole thing here goes to 0. If you're not convinced, then think of it as like this: n tends to infinity of let me think. Don't forget this is a constant. So hang on. So you're trying to do this here: natural log of 4 over. You see, this is a constant, so you can take it out here. So it becomes natural log of 4, and then lim n tends to infinity of 4n over 7n. You can see that as n tends to infinity, the denominator will get much bigger than the numerator. So this thing here is going to be 0 times this constant. It will be 0. So the point here is that this thing here will head towards 0. This thing here will head towards 0. This is going to be 1. So basically, this is going to disappear, leaving you natural log of 7 over 1, which is natural log of 7. So the whole thing here will head towards natural log of 7. So natural log of 7. So earlier we said natural log y equals so natural log of y equals this thing here. So that will imply y equals 7. So that will imply y equals 7, meaning the whole limit. Because originally we said let this thing here be y. So now that we know y is 7, so we can say this whole thing here is 7. So the limit here is 7. Okay, next question. So find the limit of this sequence as n tends to infinity. So press pause and have a go. Okay, so to do this, let's so here if you look at this, here you've got one block multiplying another block. As n tends to infinity, this thing here is going to go to 0. Cos of 0 will be 1. 1 take away 1, that would be 0. So this whole block here will be 0. As n tends to infinity, this block here will be infinity. So you've got an indeterminate form. So here you've got a product. Use that trick that we've always used in the past. Rewrite a product as a quotient. So rewrite it as this. Now let's check it again. So as n tends to infinity, this whole thing here will be 0. This whole thing here, as n tends to infinity, this thing here will be 0. So here we've got 0 over 0, which is an indeterminate form. So which means you can apply L'Hopital's rule. So differentiate the top, that will then give you this. Differentiate the bottom, that will then give you this. And then exactly the same divided by exactly the same, leaving you with this. So now if you look at this, as n tends to infinity, this is going to be 0. Sine of 0 is 0. Nothing really breaks down. So the limit is actually 0. Okay.